Good morning, good afternoon, and welcome to the December Pacific Northwest Drought Early Warning System Drought and Climate Outlook webinar. My name is Britt Parker, and I am with the National Integrated Drought Information System. This is a bi-monthly webinar series hosted by NIDIS, the USDA Northwest Climate Hub, and the Oregon Climate Change Research Institute. It is designed to provide partners and other interested parties in the Pacific Northwest with timely drought and climate information. Each webinar is tailored to reflect recent current and forecasted conditions and climatic events, but will also include discussions of observed impacts and other relevant updates from across the region. Webinars and recordings and other supporting materials will be posted on drought.gov later this week, and you'll receive an email with a summary from the webinar as well as a link to the recording. After today's webinar, you'll have the opportunity to provide feedback that will help us improve this webinar series, so please take a moment and tell us what you think. Today's speakers include our climate recap and current conditions from Nick Seiler with Oregon Climate Service and Oregon State University. Andrea Baer from NOAA's National Weather Service Western Region will give us the seasonal conditions and climate outlook. We will then hear from Erica Fleshman from Oregon State University on new synthesis relevant to the Northwest from the 5th National Climate Assessment. And we'll wrap up today with Chris Conrad from the U.S. Geological Survey, discussing new base flow forecasts that are available for sites with real-time stream flow across the U.S. We will be using the Q&A box at the right of your screen for questions during the presentations, and we'll address those and additional questions during the Q&A period after the 4 presentations are done. Before we begin the presentations, we wanted to highlight the partners who make this webinar series possible. The Northwest Climate Hub develops and delivers science-based region-specific technologies and practical information that will assist agricultural and natural resource managers with climate-informed decision-making in Idaho, Washington, Oregon, and Alaska. Visit the website listed here and in the chat box to get more information. The Oregon Climate Change Research Institute is a network of dozens of researchers at Oregon's public universities that work closely with other public and private entities. OCRI is housed at Oregon State University. OCRI advances understanding of regional climate impacts and adaptation and cultivates climate-informed communities. And again, the link for more information will be in the chat box. NIDIS was established in 2006 by public law with a mission to improve the nation's capacity to proactively manage drought-related risks by providing those affected with the best available information and resources to assess the potential for drought and to better prepare for, mitigate, and respond to the effects of drought. NIDIS is building the foundation of a national drought early warning system through the development of regional DEWS, where networks of partners and stakeholders share information and actions that help communities cope with drought. While the ultimate goal is a national early warning system, we recognize that impacts and early warning information differ across the regions. Each DEWS has many of the same base ingredients, but ultimately have their own flavor to reflect the needs of their region. The Pacific Northwest DEWS was officially launched in February of 2016, and our strategic plan and information on current activities is available on drought.gov. To facilitate our early warning system, more precipitation observations are needed. We encourage you to join CocoRoss, the Community Collaborative Rain, Hail, and Snow Network. This is a unique nonprofit community-based network of volunteers of all ages and backgrounds working together to measure and map precipitation, including rain, hail, and snow, as well as condition reporting. Observation by CocoRoss observers of precipitation events or the lack of precipitation are important to capture and improve our understanding of weather. To become a volunteer or to learn more, visit cocoross.org or contact your state coordinator, and we will put their names and emails in the chat box. NIDIS recently released a funding opportunity intended to provide support for tribal nations to implement activities that address current and future drought risk on tribal lands across the West in the context of a changing climate. Funding of up to $700,000 per project is available to be disseminated in year 1 and expended over 3 years. Information on the competition can be found in the link in the chat box, as well as resources for applicants. And if you have any questions, you can also reach out directly to me at brit.parker@noaa.gov. Full proposals are due February 15th, and while our letter of intent period has closed, you do not need to have submitted a letter of intent to submit a full proposal. Finally, earlier this year, NIDIS and the USDA Climate Hubs hosted a workshop to explore how drought assessment might need to evolve to account for climate change. A technical memorandum has been released that captures gaps and needs organized around 15 focus areas. We also have a web presence on drought.gov where you can learn more, view the report, and see projects that are addressing priority actions and research questions in the report. And links will be dropped into the chat box. And with that, I want to turn it over to Nick Seiler, who will be our first speaker. Give me 1 second. Okay, Nick, it should be coming your way.
All right, thanks, Britt. Can everybody hear me?
Yes, we can.
Okay. My name is Nick Seiler. I'm an assistant professor of atmospheric science at Oregon State. I'm also the associate state climatologist for the state of Oregon. So today I'll just be updating you on current drought conditions in the Pacific Northwest. This image in the background here is from December 7th on Snoqualmie Pass, crossing the Cascades in Washington State. This was one of a series of very wet atmospheric rivers that came through the region. This one in particular closed Snoqualmie Pass due to the heavy wet snow conditions. So we'll be talking a bit more about that in the next 10 minutes. All right, so here's the current drought conditions, current as of last Tuesday. And you can see not too bad overall. Only 22% of the region is in drought conditions, meaning D1 or D2. That percentage increases to more than half if we're including the D0 designation abnormally dry. But crucially, only 0% of the region, none of the region is in extreme or exceptional drought. So if we compare these conditions, this table on the top right shows the percentage of the region that's in each of these designated drought categories. So comparing these current conditions to really any of these benchmarks listed in the table, you can see that conditions have improved significantly. A year ago, almost 10% of the region was in extreme or exceptional drought, and more than half of the region was in D1 or above. So conditions have certainly improved since then, and there were similar numbers at the start of the calendar year. And even since the start of the water year, October 1, we've seen a significant decrease in the percentage of the region that was in any sort of drought classification. And at that time, more than 7% of the region was in D3 drought. You just compare the current conditions to the beginning of the water year. We see, again, very similar spatial pattern here, just decrease in drought conditions pretty much across the board. In the last presentation, Larry O'Neill, the state climatologist for Oregon, referred to the Medford-Missoula line, this sort of line between Medford and Missoula, separating regions of drought to the northwest from regions with no drought to the southeast of that line. You can still see evidence of that line. It's just that region to the northwest, drought conditions have improved significantly. Most of this improvement has happened since mid-November. So if we look at the picture at the beginning of the water year, early October, with the picture in mid-November, there was some improvement by mid-November, especially in Oregon and in western Montana. But really, there had been no improvement at all on the west slopes of the Washington Cascades. But then if we compare mid-November to the current conditions, again, we see that most of this improvement that we've seen over the water year has happened since mid-November. So the reason for this is that starting end of November into early December, we had a series of atmospheric rivers come through the region. There were 4 that came through just in that first week and a half of December. This is an animation spanning just 24 hours, showing satellite images taken from NASA. And this was one of the big atmospheric rivers that impacted the region. And it brought widespread flooding to both Western Washington and Western Oregon. This is an image taken from the Associated Press in Tillamook on the Oregon coast, just showing flooding as a result of that event. This map shows the precipitation anomaly as a percent of normal during this 2-week period from November 29th to December 13th. And you can see almost all of the region had above average precipitation, and much of the region, it was much above average, more than 170% of normal. But there were some exceptions to this, particularly in the Klamath Basin in South Central Oregon, and also in the Upper Snake Basin. These were regions that received very little precipitation from this series of atmospheric rivers, and that had resulted in relatively low stream flows in these regions. So over this image just shows stream flows again as a percentage of average across the region. This was current as of last Thursday, and we haven't seen significant precipitation since then. So I would expect some of these percentages to be a bit lower, especially in Western Oregon and Western Washington. But most of the region stream flows are at or above average. But the exception again is in the Klamath Basin and in the Upper Snake, where there are several gauges that are approaching record lows in these regions. So these are not regions that are currently in drought conditions, but these are regions that we'll be monitoring closely for potential drought designations moving forward. If we zoom out a bit and look at the percentages relative to the water year so far, we see on average, roughly average precipitation across most of the Pacific Northwest, a bit below average on the west slopes of the Washington Cascades, above average in eastern Washington, still a bit below average in much of Idaho and western Montana. But these percentages are not huge departures from average. And we see something similar if we look at the basin scale. So this is based on high elevation snowtel stations, snowfall telemetry stations. So these exclude all the low elevation sites that were included in the previous map. But we see a similar picture at this basin scale. All the greens are percentages that are within 10% of average for this time in the water year. Yellows are a bit below average, light blues are a bit above average, but really you have to move outside of the Pacific Northwest region, east of the Continental Divide, to see basins where precipitation is still substantially below average. But the picture is not as pretty if we look at snowpack. This shows the same percentiles based on or divided by river basin, but now for accumulated snowpack at these high elevation sites. I'm just going to toggle back and forth here again, and we see pretty much across the board, with the exception of a couple basins in southwest Idaho and southeastern Oregon, we see a significantly lower percentiles of snowpack than we do of precipitation. And the reason for this is that this series of atmospheric rivers that came through was unusually warm. And in fact, in much of western and central Oregon, temperatures during this 2-week period during which we had this string of atmospheric rivers were more than 4 degrees Fahrenheit above average. And we can look at that in percentile terms. And in parts of Western and Central Oregon, this was actually a record warm early December during this period of intense precipitation. So this was a period where we had a lot of precipitation accumulating, but at least in some regions, not a lot of snowpack. So just to give an example of this, this is a figure showing precipitation accumulation relative to snowpack accumulation or snow water equivalent or SWE accumulation. The gray line here shows the median for the 30 water years between 1990 and 2020. So this is the sort of average precipitation that would occur beginning on October 1st, the start of the water year. The black line shows observed precipitation for this year. So you can see, starting about, or by December 1st, we were running a deficit at this particular site in the Central Oregon Cascades, Santiam Pass. But then as a result of this parade of atmospheric rivers, we had 10 inches of precipitation accumulate in the span of just a week and a half. And that brought us to a bit above average actually at this site. The red line though shows the median snowpack accumulation as measured in snow water equivalent. And the blue line is the snow water equivalent at this station for this water year. So during this period of atmospheric rivers, we had an initial spike in snow water equivalent, but then that snow water equivalent decreased as a result of rain on snow, and much of that snow has since melted. So there's only been 1.8 inches of snowpack accumulation during this period where there was significant precipitation. I would like to emphasize, it's still early in the accumulation season, so there's plenty of time to recover from this snowpack deficit. However, if we look at the seasonal forecast from the Climate Prediction Center, we see that above average temperatures are likely across the Pacific Northwest for December through February. And precipitation, we have sort of equal chances of above and below average precipitation. So this suggests an elevated risk of snow drought, meaning low snow water equivalent values, kind of independent of what happens with precipitation. Even if precipitation is close to normal, especially at the lower elevation sites, where snow tends to fall close to the freezing point, we're likely to see lower than average snowpack accumulation. So just to summarize here, drought conditions in the Pacific Northwest have improved since the start of the water year. They've also improved since the start of the calendar year and since a year ago. There are currently no regions in extreme or exceptional drought, and only 6% of the Pacific Northwest is in severe drought. So that's a big improvement relative to October 1st. Most of this improvement has happened just in the last few weeks as a result of a series of atmospheric rivers. But these atmospheric rivers have been very warm, and so over much of the region, they've resulted in relatively little snowpack accumulation. And looking forward, warmer than average temperatures are likely to persist through the winter. This is likely due in part to El Nino, but this statement is just based on what the Climate Prediction Center has forecast. And again, this implies an elevated risk of snow drought. So with that, I'll turn it over to the next speaker.
Great, thank you so much, Nick. And I will turn it over to you, Andrea. Tell us about the outlook.
Okay. And everything look and sound good, Britt?
It does, thank you.
Okay, thank you. Good morning and afternoon, everyone. I'm Andrea Bear. I'm with the National Weather Service at the Western Region office, Western Region Headquarters office. And I'm going to talk a little bit about El Nino before I get into the outlook information. And with this graphic I'm showing here on this first slide, I just want to point out that the season that included September, October, and November ended up being about 1.8 degrees C above average. But in November, which this map is showing here, the value was 2.0 degrees C. So that ranked about 5th for the month of November for all of the past El Nino events. So we are looking at, we definitely have a respectable event going. It is considered strong, but we could see, if we continue to see temperatures in the Pacific Ocean around that 2.0, we could see it ranking above up where the records are with the stronger El Niños. So we'll see how it goes in the next couple of months, but it is looking good so far that it will be amongst some of the historic ones. And let's see, move on to slide 2. Sorry, I have a had to switch switch monitors here, so I'm a little discombobulated. But our Climate Prediction Center has an El Nino advisory out right now, and conditions are definitely being observed out there. The sea surface temperatures, this is an ocean atmospheric coupled system, so the sea surface temperatures are looking very good. I'll show you those in just a minute. But also the tropical Pacific atmosphere is very consistent with El Nino. In fact, the signal is approximately in about the top third of all El Nino events for this time of year. So everything looking really good right now. For El Nino, that is. And as we move into the Nino 3.4 region, the weekly sea surface temperatures are showing us currently at 2.0. But with that red arrow over here, I just want to show that that where we're at, we're pretty good. We've had a pretty good bump in warm water in the month of November. And I'll show you the subsurface now. But basically, the subsurface, which is the top 300 meters of the surface in the Pacific, has increased from October through late November. You can see this nice bump right here. Hopefully my pointer is working. But December, we did have those decrease just a little bit. I do want to say that the amount of warm water is lagging behind what we have seen in the 2 top El Nino events, but it's still a very respectable warm pool out there, and it will keep things going for the next couple of months at the strength that it's at. Here's the forecast outlook from the Climate Prediction Center and the International Research Institute. And it's expected El Nino to continue through our summer, through the March, April, May season, with a transition to neutral after that, these gray bars. I will say right now it's looking like we have an equal chance of going back into La Niña or staying in neutral conditions starting during the July, August, and September season. But I wouldn't put a whole lot into that yet. That's pretty far out. It's just something that the models are starting to hint at. So something to watch, but nothing to worry about yet. And this came from the latest ENSO blog on climate.gov, and it shows how this event has evolved, starting with September of 2022 in our La Niña event, quickly transitioning out of there as we hit the beginning of 2023, and then the ramp up to where we're at right now. And you can see the stronger events just above that. So it's a pretty respectable event. This shows the precipitation that occurred during the strongest 7 El Nino events for winter time. And a lot of variability there. These top 4 up here, these particular years were precipitation-wise were very good for the Pacific Northwest in a lot of areas, especially along the West Coast, but not so much with the bottom 3. So I put this in here just to show that we do have a lot of variability, and we can't put all of our forecast eggs in the El Nino basket. But it does help us to understand generally where we are probably going to be going, but lots of variability in there. And these are the typical wintertime impacts. This is a global view, and you can see that warm area is typical for a good portion of the Pacific Northwest, which, as Nick just mentioned, you know, even if we do have above normal precipitation, there's still a good chance of snow drought in the Pacific Northwest, or elevated risk. I shouldn't say a good risk, but an elevated chance for that, like he said. So keep in mind, El Nino is associated with these specific impacts, these changes to the weather and the climate system. The stronger an El Nino event, the more likely we are to see these typical impacts. So it doesn't necessarily mean we're going to see stronger impacts. It just means our forecasters are a little more confident that the usual is more possible. Nick already showed these, but I just want to mention that they are heavily focused on El Nino. The forecasters are definitely taking that strongly into account. But I also want to mention these are pretty stale. They're about a month old now, and our new ones will be released on Thursday of this week. So I would look back. I don't anticipate them to look terribly different from this, because again, the El Nino signal is driving a lot of the forecast, what they're putting on these outlooks here. But definitely they will be updated on Thursday, so I'd check back on the CPC website. And I do have that website link right there. I want to point out that, you know, like I said, El Nino is just one thing that our forecasters take into account. They also take into account the trends, but that just gives you some general guidance. I would strongly recommend you keep an eye on the shorter range forecasts. These are our weeks 3-4 temperature outlooks. So these are current. They were put out last Friday. They're updated every Friday. And so the valid time is December 30th through the 12th of January. And definitely the signal looking very El Nino-ish. You know, looking warmer and a bit on the equal chances. So not a lot telling our forecasters one way or the other, could go any way. But as you move further inland, a slight chance for below precipitation, below average precipitation. So I would, as you go through the winter, these are updated every day, looking at the 6 to 10 day outlooks and the 8 to 14 day outlooks in particular. These are a little bit old. I was just on a call, and they will be updated at, one more hour. So another hour, these will be out. Unfortunately, the call just doesn't coincide with when they're updated. But Monday's always a good day to look at these. And they're not going to change that much. Actually, they look a lot like this for today for the 8 to 14 day outlooks. And again, favoring warm and slight elevated chance for above normal precipitation for a good portion of the western side of the Pacific Northwest as we move inland more on the below normal side. So that's the 8 to 14 day. And then I want to point out a product I look at all the time, and it's the 8 to 14 day hazards outlook. And it shows you where we're expecting a risk of certain hazards. So these are the 3 maps. I didn't put temperatures on there because there is really nothing on there to show you. So as far as, I'll start over here on the right hand side, the risk for heavy precipitation. This will look a little different when these come out in about an hour, and they are stretching that up a little further north into Washington. So a slight risk for heavier precipitation from Christmas to the week after, several days after, just before New Year's. So I would check back on these. Again, they're updated daily. And risk of winds, that's going to change just a little bit. I think they're moving that a little further north as well into the Pacific Northwest. And then they are talking about a shape for the much higher elevations in the Cascades for risk of heavy snow. And so the drought outlooks, the monthly drought outlook will come out along with the seasonal. Those will be out Thursday as well. So these are a bit stale. But looking at the Pacific Northwest, either drought expected to persist or removal likely in some areas along the very western side of both states, and remains but improves. So I don't know exactly at this point how this may change. So I would check back with that on Thursday. And then just to sum up, again, El Nino is definitely a good event, strong event, and potentially getting up there with the most historic strong events. So we'll see how that plays out in the next 2 months. And thank you for your time.
Great, thank you, Andrea. Well, we have one question in the chat box that I'm not sure either of our speakers will want to answer, given it's about water restriction, but it's if the snowpack continues to be below normal for this winter season, which seems likely, how big of a concern is there with possible water restrictions for the summer, especially for East Washington? And perhaps if one of you would like to just talk about drought conditions generally in that area, and then I'm happy to link that the person asking the question with someone from Washington State.
Oh, yeah, that's a tough one because obviously the Weather Service doesn't provide any information. Those are decisions probably based on our forecast information, but yeah, we don't provide any or we don't have anything to do with restrictions. I'm not quite sure, other than what Nick has said and what I just showed you in the forecast, that we do have an elevated risk for snow drought. So it would depend on which areas really depend on snow for their water supply in the spring. I don't know, Nick, if you have anything to add to that, or maybe the USGS speaker at the end.
Yeah, that was my reaction too, just that, I mean, it really depends on what part of Eastern Washington you're talking about. I guess since they were referring to snow drought, I assume, they're maybe on the east slopes of the Cascades that rely on snowmelt. I still can't answer that question specifically. I will say that region east of the Cascades is actually one region where there are significant positive correlations between precipitation and ENSO. So during El Nino years, that region actually does get above average precipitation usually. That doesn't necessarily imply higher than average snowpack, again, just because of that correlation with temperature. But I think that's a region where more so than the rest of the Pacific Northwest is likely to receive above average precipitation over the next winter.
Great, thank you both. And with that, I'll turn it over to Erica.
Great, thank you. I'm Erica Fleischman. I'm director of the Oregon Climate Change Research Institute and a professor at Oregon State University. And Britt asked me to provide an overview of the 5th National Climate Assessments chapter on the Northwest. If you could move to the next slide, please. The 5th National Climate Assessment came out last month. The National Climate Assessments are congressionally mandated under the U.S. Global Change Research Program. So Congress mandates that not less than every 4 years, and these generally have come out about every 4 years, that there is an analysis of the effect of global change on diverse sectors across the country. And so the National Climate Assessments are arranged to address physical science, so advances in understanding of the physical science of climate change, to deal with nationally relevant topics such as agriculture, forestry. There are a number of sectors, economics, that are nationally applicable. And then there are chapters on a number of different regions across the country, and also on a couple of special topics. And I did not remember to put a URL here, but you can use your excellent internet search skills and just type 5th National Climate Assessment and it will pop up. One of the reasons that the National Climate Assessment is considered so authoritative is that it goes through an extensive review process government staff, external subject matter experts, the public, the National Academies of Science. Again and again and again, there are reviews of the content to make sure that it is scientifically accurate and also to maximize the accessibility of the information. Next, please. One of the attributes of the National Climate Assessment, so everything I'm saying right now is applicable to the Northwest chapter as well as the National Climate Assessment in general, is that there are extensive characterizations of confidence and likelihood. So confidence is dealing with scientific evidence, with the accuracy of the methods that are used to look at climate trends and effects, the consistency across scientific information sources. There are 4 classes of confidence ranging from very high to low. Those are not associated with numeric values. Likelihood then is an indication of certainty that is there are 7 classes of likelihood in the National Climate Assessment, and those are associated with numbers. So for example, virtually certain, which is the strongest level of certainty, is 99 to 100%. Likely, which is the 3rd strongest, is 66 to 100%. And that all sounds well and good, but what does it look like? 2 examples here. So one is snow cover will decrease and snow will melt earlier. So very likely and high confidence. Drought impacts are increasing, medium confidence. Next, please. So the National Climate Assessment deals with information that exists and, largely speaking, has been published, usually in the peer-reviewed literature, in some cases in the pretty credible gray literature. And so in a sense, there is nothing new in the National Climate Assessment, but the way that the information is synthesized is new. And speaking as one of the Northwest chapter authors, people make a pretty strong effort to not say things that people are going to go, tell me something I didn't know already from a gazillion sources. So there's a pretty strong effort made to at least synthesize material in a novel way. And these are the areas that we're focused on for the Northwest chapter in the 5th assessment. The chapter also addresses physical changes in the climate across the Northwest, so things like warming, changes in the amount of precipitation falling as rain versus snow, addressed increases in the intensity of atmospheric rivers, some of the variation in local sea level rise, depending on subsidence versus accretion at different levels along the coast. Next, please. So what I'm going to do is talk about a couple of areas that we're focused on in each of those areas of emphasis. So with respect to frontline communities, the Northwest chapter is really focusing on low-income urban communities, communities of color, tribal communities, and there was a pretty strong emphasis on urban heat islands and the extent to which those are disproportionately located in disadvantaged areas. Next. So if you take a look at the city of Portland, for example, I mean, Portland, it's a city, it's hotter than the surrounding areas, but those heat effects are really exacerbated in areas that formerly were redlined or where basically it was very difficult to get a mortgage, and areas that were where the populations were historically disadvantaged. So you can get a really good sense of the extent to which those heat island effects are exacerbated disproportionately. Next, please. The Northwest chapter also addressed some of the unintended consequences of adaptation to climate change in urban areas. So green infrastructure tends to lead to gentrification, or it tends to lead to an increase in real estate values in the areas that become greener. It also addressed the fact that as there are increases, especially in extreme heat, and as energy transitions to renewables, and there's sort of a short-term increase in costs as a result of that transition, that those costs can be translated to consumers from the utilities, and those burdens of increases in utility costs are unequal. So next, please. With respect to ecosystem changes, that the Northwest chapter really emphasized the interaction between climate change and habitat loss, and what that can mean with respect to adaptation capacity of organisms. So basically, in areas where natural land cover already has been fragmented by a long history of human activity, areas where populations are small and isolated, there's much less adaptive capacity. As a rule of thumb, We addressed the fact that a lot of the effects of climate change on organisms may relate not only to, say, the physiological capacity of the organisms, but to changes in competitive dynamics, so interactions among species. And the fact that in many cases, non-native invasive species, for example, non-native grasses, use of the cascades that tend to increase fire likelihood, that invasives tend to respond pretty well from the species point of view to climate change, and some of the natives not quite as well. That's a pretty difficult thing to model in some cases. So next, please. With respect to economics and well-being, the chapter addressed in part some of the agricultural changes, both the social aspects, so for example, exposure of agricultural workers, and the fact that, for example, warmer autumns tend to be associated with failure of honeybee colonies in the following spring. So a lot of effects of the climate changes on the economy of the Northwest. Also address some of the crop insurance losses. So next, please. Increasing agricultural losses through drought, and so this is illustrating where crop insurance payouts have been increasing across the region as a whole. Next, please. With respect to infrastructure and resilience, the chapter emphasized the fact that small rural water providers can be quite vulnerable because they usually depend on a single water source, and they have limited financial resources for various types of upgrades. About 30% of households in the Northwest use septic to treat their wastewater, and as sea level rises and extreme precipitation becomes more common, and stream flows associated with that precipitation, and the increase in rain versus snow become more common, septic tends to be not as effective. The chapter also addressed in many ways the changing electricity demand as a result of extremes and also of electrification of transportation. So next, please. In the Northwest, transportation is far and away the major source of emissions of greenhouse gases. And so efforts to electrify the transportation sector will decrease emissions, but over the short term may place some additional stresses on the energy system in terms of capacity and also cost. Next. The chapter addressed health inequities and really emphasized not only the physical health effects of climate extremes, but also the mental health effects. And in agricultural systems and rural areas, as well as in areas that are more urbanized. There's an association between increases in temperature and an increase in violence and self-harm, a lot of stress on both physical and mental health created by droughts and other extremes. And next, please. The chapter addressed the fact that there are burdens on the healthcare system with a lot of extremes that are related to climate change, not only in terms of the burdens created by taking care of people affected by the extreme event per se, so for example, exacerbated asthma as a result of wildfire smoke, but the fact that then the healthcare system is less able to provide for people that have routine or scheduled healthcare needs. Next, please. The chapter addressed heritage and sense of place, so disruptions to supply chains, food systems. A lot of people in the Northwest are moving to the wildland-urban interface, which is expanding, and so you have increased exposure to flood and fire in that interface. There can be some pretty, academically interesting, but difficult changes in home values. So areas, for example, with waterfront properties, as they're exposed to algal blooms, real estate values can go down. And then also addressing some of the shifts in recreational opportunities. So obviously fewer opportunities related to the snow industry, but shifts in timing and shifts in risk associated with, for example, water sports. So more demand for water sports in a hotter environment, but more variable flows, and often flows earlier in the year that are suitable for things like rafting. So next slide, and this is the last substantive slide. This is illustrating what's happening with carbon dioxide emissions in the different states in what's often called the Northwest. Generally speaking, a slowing of the rate at which carbon dioxide emissions are increasing, but still an increase. So a lot of efforts to continue in the COVID sense, flattening the curve and allowing social systems and natural systems time to adapt. So you can read all about these things in the 5th National Climate Assessment, which is online. I don't think PDFs of all the chapters are up yet, but online content is up. And the last slide, thank you very much, Britt, has my email address. So thank you.
Great, thank you so much, Erica. I'm going to go ahead and transition to Chris, and then we will take questions at the end. And Chris, you should see the screen sharing. Perfect.
Okay, thanks, Britt. Greetings, everybody. I'd like to introduce a new USGS website that provides forecasts of base flow for gauge sites across the US that have real-time stream flow information. And so why base flow? Well, base flow is the reliable portion of stream flow. So base flow forecasts represent the minimum flow that's likely to occur during persistently dry weather, such as during a drought. So low flows in rivers and streams can trigger a variety of management actions. Water use can be reduced or changed to groundwater sources. Appropriations may have to be curtailed because of junior water rights. Additional water may have to be released from reservoirs, or water sometimes has to be leased for in-stream or out-of-stream uses. So drought planning and mitigation can benefit from having advanced notice of potential low flow conditions. NOAA provides, through the River Forecast Office, provides streamflow forecasts at over 3,000 sites across the US. And likewise, many reservoir operators, such as the Army Corps of Engineers, Bureau of Reclamation, and large utilities, have operational hydrologic models with forecasting capabilities. But there's still a lot of streams where forecasts aren't available, and this leaves state agencies and smaller utilities, tribes, and other resource managers without forecasts at these locations. So just a couple of words about low flow forecasting. It's different than just kind of putting together a hydrologic model and calibrating it. Models really have to be calibrated for low flows because the errors are small in terms of discharge, but in terms of percentages, it can be large, quite large. So typically, you have to make a special effort to calibrate models for low flows. The worst case scenario for low flows is no partition or snow melt. And this is different than floods, because in a flood, the worst case scenario is something we don't know. It's a lot of precipitation, it's a lot of snow melt. As a consequence, we see low flows over multiple year periods typically aren't skewed like floods. Extreme low flows may not be that much less than a typical low flow. So these really makes low flow forecasting in some ways easier than flood forecasting. USGS has a base flow separation model that's been calibrated at more than 13,000 sites in the US. Most of these are USGS gauges, but it also includes gauges that are operated by the Washington Department of Ecology. And the model can be used to forecast stream flow for this worst case scenario, so just persistently dry weather, at about 7,000 active sites that have real-time stream flow. The model is, it's basically a very simple hydrologic simulation model. It has, observed stream flow is the input, and then stream flow is generated through a couple of different processes, direct runoff from saturated surfaces. But the main thing is that there are two reservoirs, storage reservoirs in the model that conceptually they represent hill slope soils and an alluvial aquifer or groundwater. and drainage from those reservoirs then generates stream flow over time. The model can be run forward in time to predict base flow recession, and again, for a scenario where there's no new precip, no additional snowmelt. And storage in the model has to be updated using observed stream flow anytime there is precipitation or increase in snowmelt. So some important limitations on how the model kind of works and how it can be used. So we have a website up. The web address is at the top of the page. You can see, and then these are just some screenshots showing what the website looks like. To access forecasts, there's a map, and you can zoom into a stream of interest. And if you click on a point on a stream, one of the blue circles, you'll get a little pop-up that has a link to a hydrograph as a PDF that you can download or view. And then likewise, there's a link to download the data as a comma delimited text file. You can also click just in a major river basin, so not on a blue dot, and you can get you can download a text file with all the forecasted daily values for sites in that major river basin or HUC4. The forecasts are updated weekly, but they aren't always available. So if the real-time data are missing when the models run, the forecasts aren't available. And we'll be working over the next few months on trying to get that perhaps a little more reliable, or perhaps be able to use older forecasts to fill in when that happens. So new site, we're still working through some issues, but so far so good. So the PDF file that has the forecast hydrograph looks like this. The first panel at the top basically has observed stream flow as the black line, and then it transitions to a dashed purple line, and that's the simulated base flow. And then there's dashed lines that represent confidence intervals for stream flow. So those confidence intervals are determined using the little plot down in panel number 2, marked with number 2, that basically just says given observed stream flow and what the model has shown or predicted simulated base flow and surface flow to be, what's the relationship there? So that gives us our 90% confidence interval for stream flow, which can be, base flow can be less than that in some cases. And then the third part of the forecast hydrograph, this plot is just some text describing stream flow that was observed, and then what happens if there is no rainfall or increased snowmelt in the basin. So 90% confidence intervals around stream flow and base flow simulations. So that's it. I would encourage folks, if you're interested, go check out the website. The links are down at the bottom of this slide. You can link either directly to the website, or excuse me, you can also link directly to that map, and that's the bottom link. So after reading through the website, you may not need to do that again, and you can just go to the forecast map and look at sites of interest. So the website gives low flow forecasts for thousands of sites across the U.S. I would encourage folks to use NOAA forecasts if they're available for your site. So this is really a backup for sites where NOAA doesn't have a forecast available. The forecast can be used to basically get a sense of what's the earliest date that you might reach some minimum in-stream flow at a site, or what's the lowest stream flow that is likely to occur given persistently dry weather. And the forecast can be used for planning drought response. It can also be used for giving notice of possible actions to mitigate low flows. And with that, I just thank you all for attending this webinar.
Great, thank you, Chris. So we do have a couple questions. I'll start with questions for you.
Okay.
The question is, will you have base flows for Oregon soon?
Yeah. So this site has forecasts for the entire U.S.
Great, thank you. And then the follow-up question, and I think maybe you've just answered that with your summary slide, is who are the primary users of the USGS website and what could they do with the information?
Yeah, so the primary users are going to be folks who need Streamflow forecasts, so water managers, either like with a state agency or a state water agency or a natural resource agency, fish and wildlife folks, tribes. It's folks who don't have access to forecasts through other means. So either NOAA is not forecasting Streamflow at the sites that they're interested in, or they do not have a hydrologic model and specifically an operational one that's being run to give forecasts in the future. So the idea here is to basically give folks information about what's the worst case scenario for low flows, and then that information could be used again for planning drought responses. So trying to figure out, okay, is leasing water going to be necessary? It can also be used for giving folks notice that, oh, look, there's a possibility the flows are going to hit some critical level, and that means that some set of actions are going to potentially could be happening, and you can give them a date about when the earliest is that might occur.
Great, thank you. Continuing on, there was a question about putting links in the chat box. I did do that, and we will include the links in the post-webinar summary. So hopefully those came through. The next question is, with the gauge flows, how far back in time can the stream flows be calculated in terms of long-term scales, such as decades?
I guess I don't quite understand the question. So the model it's a base flow separation model. So you can run the model to separate base flow out of historical records for whenever you would like. The model report, which I think I had a reference to the model report, we did that from 1981 up to 2020 for all the sites that we had data for. So it can be run historically, but you wouldn't be forecasting, you wouldn't be running it in forecasting mode. So, and all you have to do for running it in forecasting mode is essentially you give the model a time series of NAs, and the model then says, oh, we don't have observed stream flow, so we'll just drain the water out of these two reservoirs, and then it forecasts what stream flow is going to be.
Great, okay, so I have one more question for you, and then one, I think I'll look back. Do the uncertainty bounds also include measurement error associated with the rating curves, also challenge for National Weather Service forecasts?
No, they do not. Let me go back. The one thing that we do provide is there's a dashed line that says minimum stream flow for model calibration. So when flows get down to that level, that's where you have to be very skeptical about measurement error and certainly in forecast accuracy. But no, we don't. Currently, USGS does not have good estimates of measurement uncertainty as it varies with stream flow, and we know that there's a lot of uncertainty or poor resolution of low flows.
Great, thank you. So I did drop all the presentation or presenter emails in the chat box if you have follow-up questions. I know we are at the top of the hour, so please mark your calendar for our next webinar, which is February 26th of 2024. And we wish you all happy holidays and a happy new year, and we look forward to seeing you in February. Thank you very much to all of our speakers, and happy holidays.